Now, distance of a particular point from a given from the given line. Distance is nothing but perpendicular distance should be taken into consideration. So now here you let us take the point P x1 by 1 and a line ax plus by plus c, and it is line is intersecting the x-axis at a point Q and y-axis at a point R. So distance of the point P from the line is nothing but PM, one perpendicular line. Distance is nothing but perpendicular distance, shortest distance. Okay. So so equation of x-axis is x y equal to 0. On solving that, you are going to get x point. That means point Q, you are going to get it as a minus c by a. And in the same way, point R, you are going to get by solving this equation along with the equation of the y-axis. Equation of the y-axis is x equal to 0. So we will get y value. Y is equal to minus c by b. So that is nothing but we are going to get x-intercept and y-intercept. Already we have learned in this one in the previous session. So that is the coordinates of the r is 0 comma minus c by b. So now here whenever you take into consider here, you are going to get it PQR is a triangle and the area of the triangle is half into base into height. Here base is QR and the height is PM. QR into PM, area of the triangle PQR. So what is we need to find out actually? We need to find out PM. That is D. Okay, let us represent that one as a D. We need to find that distance of this particular point from the line AX plus BY plus C. So PM is equals to 2 into area of the triangle PQR by QR. Are you following this? So distance to find out here. So if A1, A x1 by 1, B x2 by 2, C x3 by 3, whenever you are taking area of the triangle, you can find out by using the three coordinates whenever it is given to you. So that is area of the triangle formula is half into in the modulus x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. So on substituting these values p, q, r coordinates in this formula and then simplifying this, you are going to get it as a point. Yes, on simplifying this, you are going to get it. This is area of the triangle. So area of the triangle, you are going to half into modulus of c by ab into ax1 plus by1 plus c. And this should be multiplied by 2 and divided by the QR to get the distance. Distance if you want to get 2 into area of the triangle PQR, that is you are going to get it as a modulus of C by AB into AX1 plus BY1. So let us consider this as equation number 4. So 2 points given and distance between the 2 points because we need to find out the distance between the Q and R. So distance between the 2 points formula you use, that is x2 minus x1 whole square plus y2 minus y1 whole square. And simplifying this, you are going to get QR is equals to modulus of C by AB. See here you can note one point here. And simplifying why you get the modulus. I already told previous in the previous sessions, square root of x square is nothing but mod x. Square root of x square is mod x. Square root of x square value, not simply plus or minus x. You cannot say that. Here mod x you have need to say because square root symbol itself. Here you are going to get square root of c square by a square b square. Square root of c square by a square b square. So that can be written as modulus of c by ab. And under root of a square plus b square will be as it is. So this you have to substitute in the equation number 2. So 4 and 5 are the 2 into area of the triangle PQR and it is replaced, and in the place of the QR it is replaced QR length and modulus of C by AB will be cancelled and the distance we are going to get it as a AX1 modulus in the mod AX because it is a distance. That's why it should be written in the form of the mod AX1 plus BY1 plus C under root of pi under root of a square plus b square. So this is a distance, a very important thing. And note down here, a highlight कर लिया है का distance d from any point if it is given from the line. And the previous one is proof. How do we prove it? Okay. So distance of the point from the line. Okay. This is the distance of the particular point x1 by 1 from the line ax plus by plus c equal to 0. So the distance d, it is represented by d, which is equals to modulus of ax1 plus by1 plus c by under root of a square plus b square. Now let us go for the distance between the parallel lines. L1 and L2 are the two lines which are parallel to each other. And the slope of the line L1 is equals to slope of the line L2 because slopes are given equal. Distance between the parallel lines. Parallel lines means parallel line slopes will be equal. So let us consider the equation of a line y is equals to mx plus c1, y is equals to mx plus c2. Can anyone say that where the line L1 is intersecting the, at what point the line L1 is intersecting the y axis? Where the line L1 is intersecting the y axis? At what point? Can you say? Yes. Tell me. At what point it is intersecting? Although I have given a time, you are not able to. This line L1 is intersecting the y-axis at what point? Because y-intercept is C1, 0 comma C1. Yes, did you understand? Divya, can you hear me? Not audible. One by one is okay. Let us continue here. So here, slope of line L1 and line L2 are equal. That's why both the slopes are y is equals to mx plus c1, y is equal to mx plus c2. So distance between these two parallel lines you need to find out. These two lines are parallel. So distance is nothing but perpendicular distance. Somewhere else here, you need to draw from a one point a perpendicular line to the another line. From one point on the line. So if y is equal to 0, in y is equal to mx plus c, x equal to minus c1 by m. So the point is x axis को ये किधर टच हो रहे हैं? Minus c1 by m comma 0. So one point on the x-axis, it is touching the x-axis. So the point is minus c1 by m. From there you drop the perpendicular line. So you know that perpendicular distance of a point from the line is modulus of ax1 plus by1 plus c1 by under root of a square plus b square. So y is equals to mx plus mx plus c2 line you write in the general form. The general form is this one. So in this a is equals to minus m, b is equals to 1, c is equals to minus 2. And here point x1 by 1 is what here? Minus c1 by m comma 0. Because from that particular point P, we are drawing the perpendicular. Point is minus C1 by n. So D is equals to the points. I'm substituting and simplifying this. You are going to get minus modulus of C1 plus C1 minus C2 by under root of A square plus B square. Sorry, 1 plus M square. If the lines are given to you with the slopes M. So distance between the two parallel lines where y-intercept and are given to you as y-intercepts as a C1 and C2 and with the slopes m, both are having with the slopes m, is C1 minus C2 by under root of a square plus b square. Suppose if the lines are given to you in the form of ax plus by plus C1 is equal to 0 and second line is given to you in the form of ax plus by plus C2 equal to 0. So both are same only. You can write them in the form of y is equal to mx plus c. So in that situation, the slopes both will become minus a by b and y-intercepts become as a minus c1 by b and minus c2 by b. Isn't it? Both the slopes are minus a by b. And y-intercepts of the both the lines are minus c1 by b minus c2 by b. So this is c1 and c2 values. Actually, small c1, small c2. To identify the variation, it is given to you like this. Now these values, you substitute in this, what you are going to get here? D is equals to C1 minus C2, same by under root of a square plus b square I. Because, yes, see here, substitution. Under root of 1 plus minus a by b whole square. In the numerator, C2 minus C1 by b, bb will get cancelled. C2 minus C1 or C1 minus C2 is same. So if the lines are given in the slope intercept form, C1 minus C2 modulus by under root of 1 plus m square where m is a slope. If the lines are given in the form of ax plus by plus c, then the distance between the two parallel lines, the lines are parallel, their slopes are equal. Then the distance between that parallel lines is d is equals to c1 minus c2 by under root of a square plus b square. So this is the concept of distance between the parallel lines.